we need to look at distance and displacement time graphs. This is a distance time graph. We need to look at these different lines to determine what is going on. One, it travels a large distance in a small amount of time, and it does it in equal size steps. So it travels 1.5 in 1 unit, it travels another 1.5 in 1 unit, so it travels at a constant speed but at quite a high value. The second one is very similar. For every interval of time it travels more or less the same distance, but it's a smaller distance. This means it's a lower velocity, but it's a steady velocity. Here the distance does not change. If the distance does not change, it is motionless. So the velocity is 0. 4, the distance goes from a value back to 0 again, which means it goes back to its original position. We can also say that since it is a straight line, it has a constant velocity. 5 is quite interesting because as the time increases, with equal increases of time, it travels further and further, which means that as it gets steeper, it travels faster and faster. Now you need to find out the velocities at the following points from A to B, B to C, C to D, and E to F. A to B, distance divided by time, is 40 divided by 20, 2 meters a second. From B to C, the position does not change. 40 minus 40 divided by 40 is 0 divided by 40, which is 0. From C to D, the velocity changes, but the average velocity is basically the change in distance. So it travels from 40 to 150, which is 110, divided by the change in time, which is 60, gives us a value of 1.83 meters per second. The last section is EF. It travels from a position at 150 down to 0 in 40 seconds. So it's 150 divided by 40. Velocity and speed. Okay, we look at the average speed is the change in distance divided by the time taken. So we divide change in distance by time taken. That gives the average speed or average velocity. The instantaneous speed is how much it changes at that point. Now this can be changing with a graph, and it depends on what the gradient is. The steeper the gradient, the faster the speed at that point. We'll look at an example here. We find the speed or the velocity at this point here. We draw a tangent. In other words, we need to draw a triangle which is tangential to that line at that point, like this. So the gradient is the rise over run, which is 3 units divided by 6, which is roughly 0.5 meters a second. Going forward to higher up, it's going faster. At this point we need to draw another tangent and another triangle. The gradient, which is the velocity, is the rise over run. The rise is around 8, the run is around 4, so it's basically 2 meters a second. So the vertical value gives you the distance or the displacement. The horizontal value gives you the time, and the gradient gives you how the distance changes with time. In other words, distance divided by time, or displacement divided by time. That gives you the speed or the velocity.